So I'm just going to go through some of the other material I collected from different sources, which is not in the book, so it adds much more value if you're listening to this and reading the book. Landscape processes, resulting landscape features, and potential implications for how hominins may have exploited these environments. So that's much more interesting in terms of linking the archaeological evidences, climate and climate impacts on vegetation and megafauna and so on. So we are looking at processes in East Africa in terms of volcanism and tectonic faulting. Resulting landscape features include things like lava flows, crater lakes, uplifted fault flank, cliffs and escarpments, sedimented plains, wetlands and marshes that we just looked at in the previous podcast. And the changes in modern fauna associated with these, the modern fauna that are associated with these features include mole rats, klipspringer, grazing equids and bovidae, subfamily, so there's subfamily of that. What else? Baboons, waterbuck, crocodiles, rodentia, clawless otter, marsh mongoose, and so on. And the potential fossil evidence include lacustrine fauna. Lacustrine is lake-based. Fauna and flora, dry grassland flora and fauna. Fauna preferring rocky outcrops. Edaphic grasslands, grazing faunas, aquatic and amphibious faunas. And human habitat implications include safety from predation, water, not potable in all cases, foraging in drier grasslands where it's easier in terms of fauna, the bovidae that evolved to live in grasslands and savannas and maybe became food for other hunters and humans. Safety from predation and drinking water. So this is for both hominins and fauna. Foraging in edaphic grasslands, foraging in wetlands and marshy habitats. The second one looked at here is South Africa tectonic faulting, uplifted fault flank, cliffs and escarpments, sedimented plains, wetlands and marshes. So the modern fauna that are associated with these include grazing equids and bovidae with subfamily Alcelaphini, klipspringer, baboons, waterbuck, crocodiles, rodentia, clawless otter, marsh mongoose. Similar evidences, and again foraging in drier grasslands, safety from predation and drinking water, foraging in edaphic grasslands, foraging in wetlands and marshy habitats. So there is a constant interaction between tectonic changes, climate changes, landscape changes, faunal responses, and then hominin responses. Of course, there are multiple time scales involved. Hominins can migrate fast. Maybe they were more adaptive, not just genetically adaptable in terms of behavioral adaptations. So the ecosystem changes happen on a much slower time scale, so we have to keep those in mind. Nonetheless, using these kind of evidences, these are the derived arboreal mammal populations in different habitats. So forests have a higher percentage than closed woodlands, bush woodland, open woodland, suburb, shrubland, and in grassland there are basically very few. So these are the box and whisker diagram of percentages of arboreal mammals. Whiskers indicate range, boxes represent two standard deviations, and the horizontal lines are the means for each vegetative habitat grouping. Okay, so here closed woodland includes closed woodland bushland transition regions. Here, okay. Translating that also to percentage of frugivorous mammals. Here again you have percentage of terrestrial mammals, high in closed woodland, okay, in these regions, bushland, open woodland, medium density woodland, deserts, shrublands, and plains. Okay, this is just telling you that availability of resources was constantly a factor of vegetation, landscape, and there was an interaction between terrestrial mammals and percentage of frugivorous mammals. What does it indicate? As number of mammals increase, vegetation changes because mammals are also seeking certain vegetation, but frugivorous mammals also decrease along that axis. There are details which you can follow up, but what I'm trying to do here is to just give you the kind of various factors that hominins would have to deal with as they evolved over these periods that we are talking about. This is a percentage of fresh grass grazing mammals versus percentage of terrestrial mammals. Similar kind of drop here, but not such a strong relation here. Open woodland and closed woodland brushland transition, brushland in circles, and shrublands, woodlands, and so on. So bivariate plot of the percentage of total terrestrial mammals versus frugivorous mammals in vegetative habitats ranging from closed woodlands to desert. Forests are not presented in this subsequent diagrams, so that the habitats are more easily compared. Both eco-variables separate habitats according to tree cover and rainfall. In addition, the medium density of woodland of Kafue National Park has been separated from the more bushland communities because the percentage of frugivory are higher in bushland regimes. Bivariate plot of percentage of total terrestrial mammals versus fresh grass grazers in vegetative habitats ranging from closed woodlands to desert. Habitats that contain large amounts of water and thus edaphic grasslands are positioned above the 8% dashed line shown here, and these are the keys. So this is the other diagram from a separate paper that looks at typology of refugia. So this is evaluating refugia in recent human evolution in Africa. So we are going back in time and looking at the frequency of refugia. I won't go into details of the kind of refugia that are defined and the processes that form them and determine them, but I just wanted to show that the idea of refugia is a big key player in human evolution in Africa and elsewhere, of course, and still continues to play a role in terms of human interaction with natural resources, etc. Sorry, I have a scratchy throat. So these are histograms illustrating frequency of occupation of the late Pleistocene sites in eastern Africa within narrow refugia, which are the blue ones, broad refugia, which are the yellow ones, and beyond either refugia in the red ones, based on central age estimates of dated stone tool assemblages within 10,000 year bins between 10 and 130 kiloyear, indicating impersistent occupation of northern sites in the top here until 40 to 50 kiloyear onwards, whereas occupation of southern sites in the bottom has been continuous throughout the late Pleistocene. So you can see that there is a gap in the north here, but in the south there has been occupation continuous throughout this period, going from 120 to 130,000 kiloyears to 10 and 20,000 not kiloyears, years. Okay, so again, climate and climate variability and refugia and estimated human occupation, frequency of occupation were different in the north and south, which should relate to, for example, 40 to 50,000, we are in the middle of MIS 5, I think, basically in this period. Before this we were in MIS 6, so you can see the occupations in the south and vanishing in the north, and then reappearing more recently. So obviously diaspora happened within Africa into different parts and out of Africa at various times, and reverse the immigration into Africa as well later on. Okay, so much higher frequencies here in terms of narrow and broad refugia and before and beyond either refugia. And you can see that populations beyond either refugia or frequencies are generally small, except here. And here the narrow refugia frequencies are small, as well as the beyond either refugia is large in terms of the frequencies in the southern African frequency of occupation. So we can try to go back and relate these to the specific climate simulations and impacts on vegetation and primary production that we saw, but hopefully someone else will do the job of mapping those things somehow on these histograms, so that we can see the relation more specifically between the processes that created the narrow and broad refugia in these various time slots. Okay, so obviously there is a broad relation between them. Just to kind of revisit these things, the various MIS stages, maybe we should start at the bottom, going way back more than 500,000 years ago. Cooler, warmer, and then by this time Neanderthals evolve in Europe. This stage is thought to be the most similar one to MIS 1, so there is some potential speciation kind of relation between climate and appearance of Neanderthals, maybe. MIS 10, Homo erectus at Dyring Urihoc in Siberia, and no evidence here. And then we jump into our favorite MIS 6, which was cooler. So Middle Paleolithic begins here, and evidently modern humans, whatever this is, modern humans, evolves at Buri and Omo Kibish in Ethiopia. Usually it's AMH, anatomically modern humans, so this is some other notation which I should have noted. But here we are, various things, modern humans appearing at Shkul and Qafze in Israel, various places we have seen before in South Africa. Early modern humans, these are early modern humans, so EMH is early modern humans. Leave Africa to colonize the world by 130,000 years ago. So we are jumping around a little bit here, doesn't matter. So warmer conditions would have favored explorations here. Was it because of reduced rainfall and expansion of deserts? So you can go back and look at the model simulations. 74,000 year Toba eruption that we talked about, cooler. Upper Paleolithic begins by 60,000 years ago. Australia is populated by then. Upper Paleolithic cave walls painted. Neanderthals disappear here, but obviously we have already discussed how this may refer to behavioral changes, cognitive abilities, and so on, and use of various resources like dyes, marine-based resources to create paints and so on. By 24,000 years we are getting to the glacial maximum, so Americas are populated by now with clovids, and then we are into the Holocene. Okay, so let's leave this here and then come back and look at how humans have interacted with climate during the Holocene before we close out this chapter, and then go into more details of the Holocene itself in terms of the invention or evolution of agriculture during the Holocene following the end of the last glacial or last ice age. Okay.